Very good morning, friends, and in this video we are going to learn about the differentiation. So that's why I have written already D, and now I just add differentiation. Differentiation is a very important part of calculus. This is called differentiation or derivation. Now, what actually it means? If real valued function fx defined on an open interval ab and let C be a point within AB, then fx is said to be derivable or differentiable at x equal to c if limit x tends to c fx minus fc over x minus c exists finitely. Means if f is a real valued function. So real valued function means the function which takes in the real numbers in its argument and gives out the real number as its values. And if it is defined on an interval AB, open interval AB means the value should always be more than A and less than B, and these ends are not included. Like if you plot them on the line, this is A and this is B, so it should be like this. End points are not included. So the x cannot be A, x is always more than A, and the x is less than B cannot be B also. So and C is a point in between these. Anywhere it can be anywhere between A and B, and we have to find the function the differentiable if limit x tends to c fx minus fc. This is fx minus fc over x minus c exists finitely, means this limit should exist and its value should be a finite number. Now you know that we have discussed in the previous videos about the limits, that a limit said to exist if the left hand limit and the right hand limit both exist and their values are same. Okay, so now here you see that left hand limit means limit x tends to c minus fx minus fc over x minus c. This is left hand limit, but in this condition it will be called as left hand differentiation, because this left hand limit is actually giving you the idea whether the function is differentiable or not. So the right hand limit will also be called as the right hand differentiation, and this will be limit x tends to c plus fx minus fc over x minus c. Now we have to change, like in the previous video we have discussed that if you want to change this x tends to c minus as something like the h tends to 0, then what you have to do, you have to write limit h tends to 0 and then replace this x by x minus c. So this will become x minus c minus fc, and x minus h will become h. So this x minus c can be also written as c minus h. So c minus h, and this is h. So you just make x as c minus h. Means what I am doing, that we are assuming that c minus h is x. So c minus h is x, and when x tends to c, when x tends to c, then h will tends to 0, because this x is very small and it has been chosen accordingly. So this equation will become limit h tends to 0 f c minus h minus fc over h, and this is your, both these things are same. Only the difference between them, that in the first case you have x tends to c minus, and in the second case you have h tends to 0, and the h is chosen accordingly so that you don't have to worry about the sign. So we have to, this is assumption that you have to write x as c minus h, and then if x tends to c, then the h tends to 0. So here also you can write, if c minus h is x, means c minus x is h. So now if you see, if x tends to c, so c minus c will become h tends to 0. So this is our left hand differentiation. Now same thing for, if I have to convert this also something like the limit h tends to 0 form, then we have to write limit h tends to 0. Now at the place of x you write c plus h. So f c plus h minus fc over h. And here you see that when you are writing x minus c, so c minus x is h, so the here this is x minus c, so this will become minus h. Now these both are same thing, and these are the coefficients of the differentiation, left hand differentiation, and this is also called coefficient of right hand differentiation, and they are also represented as f dash x. If both of them are same, that is called the differentiation of x, or dfx over dx, means change in fx with respect to x. Now what do they really explain, means what is the significance of this? For that I need to clear some part of the screen so that you can understand it in a graphical way. Okay, let me explain you graphically what does it mean. Suppose our function represents a curve. This is my curve. It goes like this, and at this point P we are interested in finding out the slope. So this is also called gradient. Now it should match exactly. So let me redraw some part of it. This is your point C. So now we have x plotted on x-axis, and this is fx here. So this point is C. So the coordinate will be C comma fc. Now just I can take this point as P, and this value from here is x equal to C, and fc is this value fc there. Now I take a point P, I am taking here, but actually I am assuming that my point Q, this is P I have already taken, so let me make this one P. So Q is just very close to the P. However, if I make it so close, you will not be able to understand, so I am just putting it here. And this is just a point, it is little before x, and that is by what value? By h. So this value is c minus h, and the corresponding value of the function is fc minus h here. And then take one more point here, that is r, and that is little far from the, but by magnitude c only. So this is c plus h, and this is fc plus h. Okay, now if I join these two, so PR and the QR, these are the chords. So if you find the slope of these two chords, if those who have studied coordinate geometry, they understand that slope between 2 points can be found using the formula m is y2 minus y1, or the difference of ordinate over difference of abscissa, that is x2 minus x1. So using this terminology, if I try to find out the slope of this line PQ, or this PQ, so PQ is y2 minus y1, that is fc minus h minus fc over this minus this, that is c minus h minus c. So if you see this is c minus h minus c, it means this is just minus c, because c and c will cancel out. I did this because there is no space and I want to save some space. Same way, if you want to find out the chord of this line segment PR, then this will be again using same formula. Now I go for fc plus h minus fc over h. Now you see fc minus h minus fc over minus h is this value, and if write fc plus h minus fc over h, this is this value. Now if I say that the limiting value for these two, the limit h tends to 0. So if I write here limit h tends to 0, here also limit h tends to 0. If h will become 0, then q will coincide with p. So r will also coincide with p. It means the PR, QR will all be coinciding at the P, and this line, which is the tangent, will become equal to these two chords, or you can say the chord has become tangent. This is the idea of the differentiation, and the differentiation means when you're finding the change in y component over x component. This is also called the slope or the gradient. So this is all about differentiation. Now to explain this idea more in a clearer way, I would like to explain you with the help of some examples. Okay, so now to explain the idea what we just discussed few minutes before, and I have taken this one example, and with the help of this example I would like you to explain you that how you can check the differentiability or the derivability of this function at the point x is 0. Look at this function. This function has been defined as the fx is x square sine over 1 over x. This is the argument of the sine function. When x is not equal to 0, and when the function is 0 if x is 0. So it means function has been defined as x is not equal to 0, it is x square sine 1 over x, and when it is at 0, then it is 0. Now we have to check out the left hand differentiability first. So I write the formula, and I will go by limit h tends to 0. Limit h tends to 0. Here you see that c is 0 because we have to check the differentiability at 0. So c is 0 because in the previous discussion the c was the point where we were interested in finding out the differentiability of that given function. So limit h tends to 0. This will become 0 minus h minus f0 over minus h. I hope you remember. So now here I write limit h tends to 0. Now if you see this 0 minus h is nothing but minus h. So it means in this function if I place minus h, I'll get f of minus h, that is minus h square sine 1 over minus h, and minus 0. If you put the x as 0 here, then everything becomes 0, that is the value of f0 over minus h. Now minus h square is just h square, so h square sine, and you know that the sine of minus theta is minus sine theta, so this will become minus, and this is 1 over h. Now this is minus h minus cancel each other, limit h tends to 0, this h also cancel this one, so you get limit h tends to 0 h sine 1 by h. Now h is limit h tends to 0, so this value will become 0 into whatever value of sine 1 over h, and we know that the sine 1 over h, sine theta have its value fluctuating between the -1 and +1 all the time. So this can be 0 into anything fluctuating between -1 and 1, but finally it is 0. Now we'll go for the right hand differentiability, that is called as RHD. And then we'll write limit h tends to 0. At the place of 0 minus h, we'll have now 0 plus h. So f0 plus h minus f0 over h. Now 0 plus h is h. So fh, if this is fx and this is x tends to RHD, means the value of the x is little more than 0, because we are doing the right hand differentiation, means approaching the value c from the right hand side but not reaching c. It means it will always be greater than c. So x is not equal to 0. So here if I put fh there, this will become h square sine 1 over h over h. This is limit h tends to 0. So now this is again h sine 1 by h, limit h tends to 0. This value is also 0, just like this one. And here you see that the both left hand derivative and the right hand derivative both are existing, giving a finite value 0. So you can say that this function is differentiable at x equal to 0. Now if I just change my function little in a different way, but before that I have to clear this mess again. So here I just remove this x square and I just place a plain x instead of x square in the previous case. Now we have just x sine 1 over x. So now what will happen, that this is 0 minus h. So now in this condition I just go a little more precisely so that you can reconnect. This is f of minus h minus f0. This is minus h is limit h tends to 0. So this will become minus h sine 1 over minus h minus 0 over minus h is limit h tends to 0. Minus minus cancel, h cancels, you'll get minus 1 over h, and h is cancelled. Now this is sine of 1 over h. Now you know that the sine gives you the value anything between minus 1 and 1, and say this is minus anything fluctuating between minus 1 and 1. So this is precisely not any value. Now just let me check this one also. So limit h tends to 0, this will become fh minus f0 over h. So this is limit h tends to 0. Now this is h sine 1 over h over h. So h cancel. So this is giving you sine 1 over h. Now this is also fluctuating between minus 1 and 1, and this is negative of whatever is fluctuating. So in the both case they will never have the same value. So we can say that the left hand derivative LSD is not equal to RHD. Therefore the differentiation of this function at x equal to 0 does not exist. So this is all about the basic understanding of differentiation. In the next video we'll discuss more properties and theorem based on the differentiation, limit and continuity. So keep on watching and subscribe, share, and just get enlightened by the knowledge.